All right, then. This Zoom session is being brought to you by the fractal Almond Octaves S. Yes. Well, golly, let's see what we're at. Oh my God. We've fallen off the edge of the book. Lesson plan. I mean, we have, so okay, let's just turn this on. Yeah, I already turned on the final. So you have, what is it? We have 2 weeks to do it, really, and finish off everything else. And we also have these extra credit sets. You know what? I think I'll just start with that. We'll do a little bit about each of these. We'll have time. I think I'll start with the big one, hourly trigonometry. This is something I wrote up about something I call hourly trigonometry. And I define an hour as 1/24th of a circle. That's 15 degrees. And call an angle hourly if it's a whole number multiple of 15 degrees. So 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 145, and 180. Call an angle triangle hourly if all of its angles are hourly. Here are the three right hourly triangles. 45, 45, 90, 60, 30, 90, and 75, 15, 90. We already know about these two with sides 1, 1, and root 2, with sides 1, root 3, and 2. What about the 15, 75, 90 triangle? What are its? Well, all right. I have here in the extra credit set an example of we started with this triangle with these angles 15, 30, this big one 45, 90 degrees, 60, 75, 45, 40, 90, and 90. Okay, so it's a bunch of hourly triangles slotted together, and we start off with the rules about the 45, 45 triangle and the 30, 60, 90 triangle with sides x, x, and x root 2 for the 45, and sides x, x root 3, and 2x for the 30, 60, 90. Okay. And so, okay, we start with AD equal to 4. And then from that, and the sides of a 30, 60, 90 triangle. If this is 4, we can figure out AB and BD. And this is AB. We figured out that, and this angle is 45 and this 45. Then we can also figure out CB. And because we know CB and DC, we can figure out CD. Because we have CD and this is a 45, 45, 90 triangle, then we can figure out these shorter sides, smaller by a factor of 1 over root 2. And let's see. Oh yes, I mean if we know side AB and BC, and this is a 36, this is a 45, 45 triangle, then we can also figure out triangle the length AC because it's root 2 times bigger than the side. And we know EC, we know AC, so we can figure out AE. And here we go. We have a 1575 triangle, and we know this side, we know this side, we know this side. And therefore, from that, we can figure out sine 15 and cos 45, what those are, ED over AD. Cos 15 and sine 45 are AE over AD. This over this over this. And then the ratio of the cosines and the sines will give you the tangents of 15 and 75. And I do ask for these last one, 50, you'll have expression with a square root over an expression with a square root. So I request that you reduce the square root by rationalizing the denominator. Okay, a point per pair, that's 6 points. And here are some other 30, 60, 90. Here's some other right hourly triangles with a 1575. And in fact, we can see it right here. This side is 4, and we can figure out 2 root 3, 2 root 2, and so on. And we'll wind up with this side being root 6 plus root 2, this root side being root 6 minus root 2, and the side being 4. So sine of 15 will be this over this, root 6 minus root 2 over 4, and that will be the cosine of 75. Cosine of 15 and the sine of 75 will be root 6 plus root 2 over 4. And the tangent will be the ratio of these two, which is why you'll need to rationalize the denominator. So here's an example. Here's another example. The big triangle is a 30, 60, 90. And here's a isosceles right triangle. Here's a 30, 60, 90. And here's a 15, 75, 90 triangle. And again, we can figure out this. We start with this side being 4, and you can figure out each of these other sides and eventually get the same ratios for the 15, 75, 90 triangle. So, okay, we have these proportions, and given these proportions for these triangles, we can complete these this table for 5 points. And when we're dividing by a sum or difference of square roots, we can reduce it by you reduce radical form. In this case, we multiply above and below by root a minus root b. That shows up at the top. And the sum of roots times the difference of roots equals the difference a minus b. And do a similar thing here to get this ratio. And so, okay, we can find these in exact values in reduced radical form. Okay, now this is a bit of a mess, but I took the trouble of drawing a single triangle, a single diagram, which if you look at it, you can find every single hourly triangle, which sides 15, 15, 150, 15, 30, 135, 15, 45, 120, 15, 60, 105, 15, 75, 90, 30, 30, 120, 30, 45, 105, 30, 90, 30, 60, 90, 30, 75, 75, 45, 45, 90, 45, 60, 60, 40, 75, 60, 60, 60. All those you can find within this diagram. Okay, now here I mentioned the we derive the law of sines. So that a over angle alpha equals b over a over sine of angle alpha equals b over sine of angle beta equals c over sine of angle gamma. We've done this before to solve triangles, so we can with a little bit of trickery write this a little bit more simply in terms for a and b in terms of a, c, and alpha, beta, and c, like this and this. And also from the area formula, half base times height, we can get this formula for the area of a triangle. We didn't do that before, and I guess we should have. I call this the angle side angle equations. Given alpha, beta, and the angles and the side c between them, the area is c squared, sine alpha, sine beta, with twice sine of the sum. So, okay, given an angle on the side, we can get the other sides and the area. So here I have something I wrote up to find, given three sides, well, given one side and the two unknown sides, and the three angles, what are the two other sides, and what's the area of the triangle? Here's for a 15, 50, 150. Here's a 15, and here I put one on the long side. Here I put one on one of the other sides. Here's a 35, 15, 135, one on the long side, find A and B and the area. Here I put one on one of the sides, find A and B in the area. Here we put one on the third side, unequal to the others, find the other sides in the area. So, okay, that's one. Then here's a 45, 15, 120, three variants. And here's a 15, 60, 150. Put one on one of the three sides, here or here or here, and find the other sides in the area. And so on. 15, 75, 90, one on the long side, find the other sides in the area, and so on, and so on, and so on, and so on, and so on. I'm coming up to, here's my favorite coming up. The 60, 75, 45 triangle. I'd never seen it before writing up this problem set. And upon making its acquaintance, I immediately fell in love with it, because it has an angle from the one type of the regular angles, 60, 60, 30, 60 triangle. Here's a 45 from 45, 45, 90. Here's a 75. So it has angles from each of these three classes of triangles. And again, find one's given one side on one of the three, find the other two sides in the area between them. I call this the jaunty triangle because it's kind of this amusing offset. And when you find A and B in an area, it'll have, well, it'll sort of look pretty much like, it'll have pieces of roots from pretty much anywhere. We'll have a root 2, a root 3, a root 5, a root 6. I find it amusing, that's all. And then, of course, here's the regular 36, the 60, 60, 60 triangle. It's fairly obvious that A and B are 1, and you can figure out area pretty easily. So, and this is 30 such problems because these are all the problems you can make up for the hourly triangles. All this contains all of the hourly triangles and put one on each one of their sides and find the rest of it. What I find great about this is that basically this is the entirety of an entire branch of mathematics. It's not that often that an entire branch of mathematics has only finitely many questions, and in this case, a fairly small number, 30, which you can do as a problem set and thus gain 30 points. Again, I require the exact values in reduced radical form for each of them. It won't do if you give me decimal approximations. No, that's not what I'm grading for. So, okay, that's what these are. And those are the hourly triangles. And so I recommend this to you. It'll certainly make up for, if you do well enough on it, it'll make up for any mistakes done anywhere else in the whole semester. So this is my recommendation. All right. Well, I think that's enough for here. We have other modules. I'll discuss those over the next week. And quite frankly, I think that this is the next 2 or 4 problem of our meetings will essentially be office hours like this. Please come to here if you have questions. Come to me, and if you have questions and requests and so on, and I'll answer them. So I think we're done for now.